A wind turbine could be used as an emergency power source in natural disasters. With all the different types of fan blade sizes out there, it's easy to find one on the internet and turn an ordinary motor into a wind turbine. But the question remains, which fan blade will generate more electricity at the same wind conditions? A small fan blade or a larger one? Well, let's find out. Our question: will using a larger fan blade in a wind turbine generate more voltage compared to a smaller fan blade? Our hypothesis is, if we use a larger fan blade for a generator, then we will be able to produce more voltage at the same wind speeds compared to a smaller fan blade. Our independent variable is the fan blade size. Our dependent variable is the voltage generated. Our controlled variables are wind speed, type of generator, the area of the experiment being performed at, the direction of the generator, and the wind direction.
Here's a list of materials I'll be using. I'm also going to need soldering equipment and a multimeter. Now it's time to construct my circuit. Here's the schematic diagram that I will be constructing on my breadboard. I'm going to start by building my diode circuit. By arranging 4 diodes in a unique way, I can make it so that when the generator is generating reverse polarities, the LEDs will still light up. This could occur when the generator is spinning in opposite directions. The circuit is very important because it can prevent the capacitor from exploding due to reverse polarities. After I check that the diode's anode and cathode are in the correct position, I attach the electrolytic capacitor to further stabilize the voltage. The only disadvantages of using a diode circuit like this is the annoying voltage drop of around 0.7 volts. Thankfully, I have used a specific diode with a very low forward voltage drop of only 0.4 volts, which is not that bad. Now I'm going to arrange 3 LEDs in parallel. This will ensure that there won't be voltage splits and only current split when the generator is spinning, which in this case it doesn't matter because the LEDs run in very low current form. And now let's test the circuit. When I spin the generator clockwise, the LEDs lights up, and when I spin it in the other direction, producing reverse polarities, the LED still lights up, proving that my diode circuit works. Now I'm going to solder this circuit onto an empty circuit board to make it last longer. Now let's measure the weights of the fan blades. The smaller fan blade is 4.8 grams. And now let's measure the heavier fan blade. The larger fan blade is around 28 grams, a lot heavier than the smaller fan blade. And now it's time to perform the experiment. My plan is to run the generator in both fan blades for 5 minutes each. I then will take the highest voltage produced in those 5 minutes and plot it on my chart. Now let's plot the data. After running the generator in both fan blades for 3 different wind speed, you can clearly see which one is producing more voltage. After analyzing the graph, you can see that my hypothesis is correct, and that the generator is really producing more voltage with a larger fan blade. I'm hoping to use my findings in this project to help developing countries get their free energy source. Finally, let's talk about how a generator works.
What is a generator? A generator is simply a device that moves a magnet near a wire to create a steady flow of electrons between the wire and the magnet. The action that forces that movement varies vastly, from hand cranks and steam engines to nuclear fission, but the concept always remains the same. In the case of our experiment, what is moving the magnet close to the electrical wire is the fan blade in the wind turbine, which is in turn being turned by the wind. Okay, good. Oh, and find a really cool song.
Yeah, I know. I don't look at that.